Check one, check two. Hi, anyone? Can you hear me that end? Just doing a mic check. Just looking for some recognition. Just a hand up in the chat would be awesome. Check it one, check two, check one. Hi Dimitri, can you do a quick mic check with me if you can hear me there? I've done no mic check and need to make sure that someone can hear me. If you
Yeah, hey Darren, yeah, I can hear you.
Good man, thank you, thanks a million. Cheers.
No worries, yeah.
Hey Lear. Okay, guys, it's just gone past the hour, so we'll wait for folk to jump on. Looks like a few folk are jumping in now, and then we can jump into this. It's been an interesting development period for the energy cost budget method. See lots of opportunities for this dual workflow to be really useful. But yeah, let's give folks a couple of minutes. There's not many people jumped on. I think there's about 45, 50 registered, something like that. But that's never an indication of really how many people will turn up to these sessions. So we'll give it a couple of minutes, wait for those invites or triggers to go off in the Outlook and all that sort of stuff, and go from there. Okay, guys, I'm just getting ready to jump into this. I think, yeah, there's a classic about 75% drop off. You never know who's going to turn up to these session. So yeah, I'm just going to crack on. I'm going to go ahead, respect your time. Thank you very much for jumping in here, guys. I really do appreciate it. My name is Darren, and yeah, I'm one of the team behind the platform. As my camera on, yes it is, and I'm going to introduce you to the energy cost budget method here today. So it's been a piece of work that we've been doing for some time, and it's been a really interesting development period. I come from a facade engineering background, building enclosure background, and I kind of jumped into the world of building simulation over 20 years ago. Started with a master's degree in the space, and effectively it honed me for using IES. Didn't know at the time, so I became quite competent in the IES space, and then jumped into various other software, and then probably about 2012 found myself in the EnergyPlus space, which was I guess nerdy for the time because no one was really using it natively. So I jumped into it, and the team that I had working with me for me at the time, we jumped into it, and we started learning a lot more about EnergyPlus. And over the years, we've I kept on top of it in order to really come up with a platform, which we'll be talking about a little bit today. Now, I've gone ahead and turned off the microphones. Sorry about that. The only reason is I tend to get disrupted. I've just turned off my own camera, and I've turned off yours. Again, apologies for that. It's just around the disruption side of things. And then for the chat, go ahead and use the chat function there, so you can fire some questions over. I probably won't see them until the end, so feel free to just give me a little bit of patience there, and then I can come back to them. So fire the questions in by all means, and I'll just roll back to them. Now we'll be punctual with our time here. I'm going to make sure that I've got a visible time there. I'm thinking about half an hour, 40 minutes. We'll fire through this, and we can then jump into those questions. Now, first of all, a shout out to the guys at Vipsa. SimBuilder's coming. We're really looking forward to attending this event. We attended the event in Brisbane there last year, and it was fantastic. Brisbane, Australia. Now we'll be over in Minneapolis. So looking forward to anyone that is going to attend this. I think we've got some of the organisers on here today. So shout out to you guys. Hey, Alan. But yeah, well worth attending. It's a great event, and if you want to come and see us there, we'll be more than happy to show you more details on the platform in a one-to-one perspective. Now, a little bit about the platform. I'm not going to go through a sales pitch here. I guess over the years, we've evolved this to be truly a platform. It was an energy modelling software, cloud native, EnergyPlus under the hood, and then it became a bit more of a platform because we put radiance on there for daylight modelling, and then we started to do carbon, and then we started to do moisture modelling. So we started to do a lot of stuff, and evolve this to be a platform where effectively you can dump all of your projects. There is even project management functions on the platform. We call it flows. Set goals, track timelines, assign tasks, all that sort of stuff. But fundamentally today we're talking about only the energy modelling side of the platform. Just be aware that we do a lot more than what I'm going to be talking about today. We've been around for 7 years, so we're not new at this at all. We honed our craft in Australia, then moved to New Zealand, and now we're moving to an international platform. Now, as it's a platform, we get to provide lots of things on that platform, from documentation to support tickets to on-demand courses, all this type of stuff. It's all available for you. Not going to explain that much further. And yes, look, we have a few clients there. A lot of them that might not make sense to a US-based audience, but these are very well-known clients or well-known companies in Australia and New Zealand. Now, that was as much of a sales pitch as you're going to get. Just wanted to cover a few things in terms of where we're at now in terms of our development cycle, if you like. So ASHRAE 2019 has been our point of interest to this point, and 90.1 we've focused on in terms of Section 11 and Appendix G. Moving forward, we've got some decisions to make around how quickly we jump into both the 2022 and 2016 versions of ASHRAE. And you can, imagine why we'd want to go backwards because of things like LEED, which are going to continue for some time, and use older versions of ASHRAE. We also have that benefit of increased jurisdictions in which people can use the platform. And, that 2016 number may even change to an earlier number if we see the need to do so. Fundamentally, because we've done 2019, the jump to 2022 and 2016 is so much easier now. Now, this is just a snapshot of what we're up to. The other part of this is the design tool side of things. So we are developing out the platform to be much lighter in the cloud. And what that means is really that things are changing. So you're going to see the platform evolve very, very quickly in front of you over the next 6 weeks, particularly from a drawing point of view. So we're bringing in more and more functionality and kind of moving away from some of the render composition that we have at the moment, where we're kind of forcing renders through EnergyPlus in a DXF form and bringing them back to the cloud, to going to 3.js and presenting things in a much more, hopefully aesthetically pleasing way, but also those tools that come with this change are going to be fundamental to effectively making geometry a process that shouldn't take more than, half an hour for a complex building. And I'll leave that there. An exciting one for me is thermal bridging. Exciting just because I've been doing thermal bridging for a long time. Obviously, ASHRAE 90.1 2022 brings in thermal bridging as almost as a formal requirement now, which is great because thermal bridging is a building enclosure point of risk, whether it's moisture or energy. It is something that we really need to look at, and we of course are looking at thermal bridging. Now there's two aspects to what we're doing here. Is the automatic detection of thermal bridges themselves. That work's already done, ready to go. Then there is the other aspect of the direct finite modeling of thermal bridging. That's also in play here. So we're also going to enable you to do direct thermal bridging on the platform in order to generate those psi values or chi values in order to input into this process. So again, we are a platform, and that's why we're looking at that. And then some other things that we just quite haven't got to: automated shading, advanced glazing, just be able to pull together those NFRC 100 systems based on ISO 15099. And we've got parts of that already, but we're, going to fill that process out a wee bit more. And the final thing there is HVAC, and more HVAC. So what we always find is when we go into new jurisdictions, let's call the US an entire jurisdiction that's divided up, we are going to find that there's some elements of HVAC design that we have to continue to build out because we don't know everything. We're not pretending to know everything. So we are going to continue to work with people to build out specific HVAC requirements that we may not have had to build out to date. Now, there you go. Let's now jump into the energy cost budget method. Just as we do, YouTube, go to ASHRAE 90.1 2019 Appendix G intro. It's presentation I gave there a little while ago. Just search for Better Building and you'll be able to get far more context about what we do. This is really just a snapshot of our thought process, our aspirations. Well, not really our aspirations anymore, because this is effectively what the platform is now doing. What this is intending to say is that, hey, Appendix G section 11, section 5, once you've effectively got your geometry, these are processes that you can, go through commonly with that geometry in order to specify, simulate, and then verify and report. So arguably, these errors could almost be backwards, but the process of, multiple dual compliance, 3 compliance pathways in this case, is pretty simple to do once you've got the basis of Appendix G, which we have, and once you have Section 11 in play, automatically Section 5 comes into play, and we can start actually looking at other sections from a prescriptive modelling requirement as well. So this is effectively our philosophy of what people should be doing. You should be doing multiple compliance workflows to see what works for you best. Now, of course, all of that is driven by the wonderful standard 90.1, and this is the standard that we've been having a deep dive into for almost probably a year now. And what we've undertaken so far is the Appendix G, and we're jumping into the energy cost budget method now. Now, just a quick touch point on EnergyPlus under the hood. We have 3 versions of EnergyPlus at the moment. I think there's a new version just came out very, 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 very recently. We won't be touching that for a while. The version that all of the ASHRAE work is running through is version 25.1, primarily because we have independently tested 25.1 against ASHRAE 140, which is a weird requirement given that EnergyPlus is by default tested, but we've had to test the front end of Better Building to make sure that it stacks up. And we've got that all published. So if you take anything away from here, it's just that version 25.1 is what you'll be using under the hood. Now, from a energy cost budget method perspective, I got to say, it's pretty complex. I probably would have said this. It was a little bit easier than what I would have thought originally. Just flicking over to that now, and I'm not going to make any assumptions about who's seen what in terms of this standard here, but it goes into a bit of depth, and the way the standard is written is that sometimes you've kind of got to find a clause, you've got to find a condition that you need to meet in the standard. So when standards are written like this, it could be one line item that is seen or that needs to be, met. And sometimes you don't see them for a while, and I've been in the case where effectively no one said anything about a standard, and it's gone 2-3 years, and then someone's caught a line item that contradicts something else, and then ultimately you have to go chasing that. The point there was that this is a pretty complex standard. It's not as easy as I would have thought. Sorry, I'm just flicking back to the presentation there. And, at the beginning I thought, 90.1 is more complex, but I'd probably argue now that this standard is more complex than 90.1. It is what it is. Both of them are pretty complex, but, there are materials that you can read to inform yourself, and probably the one that I find most useful for myself, if you haven't got a copy of the user's manual, go ahead and get that. It's always great to get an alternative read in a different way, in a different voice than the standard describes things, and we found this pretty useful. So jump in there, have a look at that. Now, this is the bit where pretty much, I don't know whether you have this term in the US about teaching people how to suck eggs. It's a weird term. Maybe it's an Australian term, but obviously there are multiple pathways that you can undertake, subject to whether they are going to be accepted. Prescriptive energy cost budget method. There's a weird typo in cost. I've got 2 C's there, and performance rating method. All of them have trade-offs potentially associated to them. Prescriptive, prescriptive doesn't have any trade-off at all. You just must meet the requirements. Great, that is what it is. The The energy cost budget method itself, you have opportunities in the building envelope, lighting, HVAC, and hot water systems, and then over in the performance rating method, you have all systems, but then you have some other complexities that may not actually make that as flexible as it may appear. What I want to talk about is the energy cost budget method here, because I think that is the most useful. Performance rating method, again, hit up that YouTube video. Let's get into the energy cost budget method, because that's the one that is the context here today. Now, strictly from a what it is question, here is a bit of a word salad here. I don't tend to use these, but it describes the energy cost budget method is an alternative approach to demonstrating compliance with the standard. It's all about whole building energy simulation to demonstrate that the proposed building annual energy cost does not exceed a budget building design. So if we look at it from a really simplistic point of view, you have a building, the building is your proposed design, you're going to design that building up. Again, this is telling you probably what you know. Then you have a budget building. That budget building is the thing that you're comparing to. So they are very similar. They do change from a window to wall ratio, etc. But they are very, very similar buildings in themselves. The budget building doesn't actually have shading on it. Proposed building does. It's just a very quick way of describing the fact that you are comparing one against the other. So in other words, the energy cost budget building there on the right represent the building as if complied with the standard. Now, again, to break things down in a really simplified manner, you have your annual energy cost calculated for the proposed building design. That's the design energy cost, and you're really just looking at that to make sure it is less than the energy cost of the budget building. So that is the annual energy cost calculated for the budget building as a function of the prescriptive requirements that are embedded within it. So that's it. That's effectively what you're doing. So there's a very simplified, I guess, summary of it, but that's the outcome. There are other things that need to be met as well, which I'll go into when we jump onto the platform. But that is the goal. Okay. So a very, very quick talk on process. This is really just to cover the fact that there are lots of things going through here. So, having your authority, having jurisdiction accept the ECB method is principle. And you need to meet all of these requirements here for section 5.4 to 10.4. You have section 6.5 or 6.6. There are power requirements over in section 8. We have other equipment requirements in section 10. And then ultimately, you can say, okay, once you've accepted that all of these need to be met, you can then jump into the energy cost budget method. So just keeping a high level, but that's effectively what needs to be accepted before you kind of jump into this. And one of the note there is that, some of these requirements are both mainly, lots of quantitative, but there are some qualitative requirements there too, worth digging into because they are what you're saying have been met via this method. Now let's jump into a model. At the last minute, I decided not to use this model. This is we just brought this in directly from, I think this came in from IES. But this model represents a good model if you want to talk about other design applications. If you want to talk about daylight design, design day, or daylight, you can go ahead and bring in a daylight assessment there, or undertake a daylight assessment. We're not going to talk about that today. But when you're talking about the energy cost budget method, I think it's probably better to break things down in a far more simplistic manner. So I think that's what I'm going to do here. I'm just going to go ahead and create a new design. And this is what I'm doing on the platform. All you're seeing is the insides of a project that happened to be in Las Vegas and happens to be to 2019. So I'm just going to go ahead and do a quick example project. And this is just to show you how to get things going. It's just going to be a 2D project. I'm just going to jump over a couple of things here that we don't need to get into, just bearing in mind what the time is. And this is a very simple box. That's all that is. We happen to be in Imperial, and that is that box there. Okay, so what we're going to do is we're going to quickly what I'm going to do, I'm going to go ahead and just pop on another box here. I don't care what the size of it is. I'll just close that. I'm going to call that zone 2, and the only reason we're doing this is just so we can see what's going on. Zone 1, there we go. Save that. I know it's a bit brutal and silly, but it's always good to start with a very simple example. I'm going to pop on some windows. Again, it doesn't make difference what I'm doing here. I'm going to add on some shading, and then what I'm going to do, I'm just going to pop that onto all orientations. Okay, so really simple. There you go. Zone 1, Zone 2. That's it. And now that DXF render is re-rendering, and it gives us something like this to look at. I know it is a silly little model, but sometimes this is going to work better from a demonstration point of view. What else will I do? What I'm going to do, I'm just going to distribute that a little bit. So instead of this is, let's say this is a typical level, and hit save, and then we're going to jump into the levels here, and I'm just going to distribute that across 5 floors. Say that the DXF render is re-rendering. Well, it will do. There we go. Let's save that, re-render, and we'll just work with this. Okay, so this we're running in Imperial. We can run in Imperial and metric. We're still doing some transition work for that, but this is our test model. Okay, it is what it is. Nothing too amazing there. And let's go back here. So what we're here to talk about is the energy cost budget method, right? We're in Las Vegas, right? So what we're going to do, we're going to quickly assume, what is it, guys? I think it's 2A or 2B. I'll let someone answer me there in the chat. I'm sure who's going to know. Alan's going to know for sure. Alan, what is it? 2B is this? Something like that? I don't know. I can't actually see there. I can't even see the chat. Oops, excuse me. I've just jumped back to the wrong area. So what have I done? There I am. I'm back. Okay. So let's say it's 2B in this particular example. And I've done that again. Okay, cool. So we're going to set up the energy cost budget method here in terms of a workflow. We're going to state that we have service hot water. All this is doing is giving us information around the baseline or the budget building in this particular example. We're going to set baseline orientation to be multiple. We're going to select our lighting method, which effectively just changes your assumptions on the LPDs. So lighting power densities, set one or the other, it doesn't make a difference. And then we're going to jump into our unmet hours. We're going to state either total hours or occupied hours, noting that there is a definition there for the occupied hours, considered hours where the thermostat is active in each zone, and the zone is occupied. From a scope perspective, we're just going to run that single, so only one baseline is assessed, meaning the average is assessed, not multiple. So that's there. That will probably disappear, I imagine. And then there's our default cooling set points. So not much to set up there. That's kind of a partial setup. Now, what we're going to do, we're going to jump into our spaces where we can nominate, lighting and equipment and these types of things. So there's lots of stuff that we can nominate here. We have a default schedules that have been imported here. Not sure whether they represent an office building. I don't think they actually do, to be quite honest. What I'm going to do, I'm going to bring in a schedule for an office building. I'm going to do something called create a tag. And again, I'm just going to distribute some information across the model around really what I determine as an office building. So an alternative schedule. And I'm just going to bring that information in here. So don't worry about that. That's another discussion. So effectively, the entire model is now inheriting this data here for occupants, for lighting. And this is our proposed design, right? This is what we want to design. All of this is exactly what we want to design. We got thermostats. They are on a backstop. We can see that there. Still some work I can see here, transitioning from metric to imperial. But we can see exactly what's happening here. We have a backstop of 15.6 degrees, and then that ramps up to 21.1 or 70 degrees Fahrenheit at 8 o'clock. And that is for all other days. We have a Sunday, we have a Saturday. These are just all assumptions. They can all change, of course. Sizing, HVAC, no HVAC on yet. Let's go ahead and turn that on. There you go, that's turned on now. And we can jump to the HVAC system itself. And then 90.1, this is the bit that we want to get to. So actually this is conveniently filled out there for an office space. So all this is telling us two things. It's telling us that there's context that we need to provide for the performance rating method, which is also here. So I'm just going to set that up at the same time. Again, what did I do? 2A. I think I did a 2A. Did I do a 2A? 2B. I did a 2B. I don't know which one is which, right? So let's say it's 2B. Might be wrong there. I'm going to set all the other inputs for the performance rating method. Again, check out the YouTube video for that. But effectively, both the performance rating method and the energy cost budget method are going to be inheriting this context information for the BPS, for the HVAC building type, for the window to wall ratio type, for the lighting power density, and then down on the energy cost budget method, we have the building type here, and you have this space type. Okay, so there's lots of options there for you to choose. These have just been chosen, and that's a big part of what we're going to do. So leaving that aside, we can then jump into the HVAC side of things, and let's build out something, a little VRF system or something like that with outside air. That would do. That air terminal is being multiplied and distributed to all of the zones. Have an air handling unit. Let's put on a heating coil onto that. Put a cooling coil onto it as well. That's fine. We'll keep it simple. On the heating coil, what did it give me? Did it give me order size? Where am I picking up that? Okay, I haven't got a chilled water loop on that one, so I'm going to just take that off for a second and leave it like that. And then if you want to go in here, you can go in here, go wild with specifying your HVAC system. Incidentally, we've got some really nice changes coming in this space where we're effectively flattening out this scheme so you can see everything all at once. But you can, go to town with this, specify as you need to specify, and it seems like a very high level simplified view, but there is a lot going on under the hood here, and you still have lots of options to specify this. And this is the area that we're going to be continuing to build out. One other thing I'll say there is that you have all your standard defaults there for ASHRAE 2019 in terms of standard systems, and again, this is the area that we'll continue to build out in terms of these schemas. So let's say that's all correct in the world, and then we're going to just jump into economics here. We can see that these are tariffs. These tariffs are needed for both of the performance rating method and the energy cost budget method, and effectively all this is doing is dumping a cost per unit for electricity, a cost per unit for gas. Obviously, these are wrong. Whatever these numbers need to be, they need to be. I'm just going to leave them at those defaults there. And anything else that you need to resolve? No, I'm going to bring this down to a smaller step size, just because I want this to run more simply, or quickly, I should say. That's almost done. One other thing. When it comes to ensuring that your prescriptive requirements are correct, you're going to have to update your surface types here for your walls, your floors, your roofs, your windows, etc. And if you jump in here, you can, using default type, you can then select the opaque assembly construction type, if you like. And if it was a wood frame building, this isn't going to be a wood frame building. Let's call it steel frame building or a metal building. These are all described in the prescriptive requirements in section 5, then you can go ahead and just update those, set your values, and run with that. So it's important that this is done, because this increases the, well, it doesn't increase the accuracy, it maintains the accuracy of the prescriptive requirements that form the baseline assumptions for this assessment. So I'm just putting in steel frame across the board and dumping in some assumptions. There you go, fixed, that's fine. And again, these are going to set up your model. That's it. Running 2 simulations now, and effectively this is running 2 simulations for all of this. The code does not support no HVAC systems. Okay, silly error by me. So what I haven't done here is I haven't correctly added on a default space, sorry, a space for the office. So I'm just going to go ahead, rebuild that. It's giving me an opportunity to just show you that again. So here I've now connected up the office space. That's done, and we can go back into the air handling unit, put on a, well, probably don't need a heating coil on this one, to be honest. Let's just we'll leave it there. Done. So when I refresh that now, those errors should be gone. Excuse me, save, refresh, and go back to core levels. Let's see if that's going to run. Again, we're just running this particular design here. So feel free to think about those questions now as those are running. So that's all baseline and budget building models running, all orientations is what I mean by that, plus the proposed design as well. So there's a lot of models running, 10 models running in parallel or something like that. So I've got to stop doing that transition. It's really weird, sorry. There we go. So let's wait for that to come through. Yeah, fire over any questions. How are we doing on timing? We're not too bad on the timing side of things. I probably could have run this previously. Models, what this is doing is just, this is running directly and returning in the browser. So effectively what this means is that it's a slightly slow experience than batch processing on the cloud. So we've got our first run back, which is our budget building, and we can jump into that, and we'll jump into the performance rating method. It's taking longer, can take longer for a multitude of reasons because of the difference in HVAC systems in the budget building. But let's jump into this first. So here is a summary of the baseline building. So in the summary, we kick off and we start with a substantiation of what we've done. You know, ASHRAE 90.1, it's in climate zone 2B, and we've stipulated an HVAC system, and that HVAC system has stipulated the system that we're comparing against, and it happens to be system 3 from an energy cost budget method perspective, and we can dive into that in a wee bit. We have a substantiation of the annual energy costs, and effectively what it's saying here is that we haven't met them. That's fine. The illustration wasn't that this is going to meet them, and we might be able to shimmy through that. But effectively the budget, the thing that we're comparing against here, is here. There it is there. 23369. Probably need to divide that by the area of the building to make it a little bit more legible. And this is the actual one that's been stipulated in this particular design. So we can see that repeated there. And if you go down, you're going to see a lot more information around effectively what's happened in these simulations. Now let's dive into the interesting stuff. There is a model verification tab here where you can kind of go through and have a little look at what has been verified in the budget building. This is the energy cost. Well, that's a bit of a repetition from the summary itself. It's just a bit more detail. But let's jump into the proposed design. Just as that runs through, it looks like the PRM is starting to time out, so I might need to run that directly on the cloud on our server. But we'll jump into the proposed unmet hours, and we can start to see a summary here saying, hey, there's a lot of unmet hours on the cooling side of things. What's that about? We can dive into more detail in a second. So there it is. It's substantiating that we're up to 190 for unmet hours for whatever reason in July. There's our PRM that's now completed. And then on the budget side of things, we can actually look at that too, and it's looking like, oh, there's a lot of unmet hours there. So we'll dive in now to substantiating that a wee bit. Where do we do that? Well, we can dive into the proposed design and the budget part design by toggling through these, okay? So you'll be able to get a good feel for what's happening in the space. And let's go through just a process of first substantiating the inputs. So lots of information here. This is where you're going to find all your answers, but let's answer the question of whether we actually, identify with what's been modelled here versus what's been modelled here. Okay, so starting off with kind of an obvious thing from an energy cost budget method, they don't have the same window to wall ratios. Okay, so we have our proposed and we have our budget. Okay, if we go to summary here, we can see 40% window to wall ratio in our budget, 70% in our proposed, because that's what I added in this random model. Okay, so we can start to substantiate windows. We can go ahead and hover over these and we can actually see the values that have been assumed. And probably a big one here is going to be the solar heat gain coefficient, the fact that in this particular climate, that is being driven down to 0.25 in the budget building. That makes it much harder on the cooling side of things for the proposed design if that is sitting at 0.35. But in a similar way, we can go to our roofs, compare those between budget and proposed, floors, walls, you get my drift. And then you can get a summary, a green blob there, and that's effectively the conditioned space in both models. And then there is our summary there, go between the proposed and budget. This is where you substantiate. This is where you go, okay, I believe in the modelling. Now let's finally get into some of the important bits around the unmet hours, because I do want to give you the chance to ask a few questions. Now let's focus on this here. A crazy amount of unmet hours there. What is going on in that budget building? So this is probably one of the better places to start to look at this, so you can jump into each zone and see what's happening in terms of the number of unmet hours on average that are being achieved. I personally prefer this view, because this view allows you to substantiate what's happening. So you've got a huge amount of cooling unmet hours, and then you've got a heating. So probably not surprising in Las Vegas. All these points here are showing you that there's a massive cluster of the building effectively having a very big issue with unmet hours. And then if we go to the heating, not much there, as you would expect. On the proposed design, less so. And we can see that because that is 645. And that is 645 if you add up 622 and 23. And then you can see the cooling there and the heating. So it gives you a quick, view of, okay, there's a lot of unmet hours, and you can also, toggle through the difference in the systems here in terms of the HVAC systems, zone sizing, toggle between the two, get a feel for what's happening. Back in the zones, once you go through the, inputs here, if you want to go ahead and export them, you can. If we look at zone loads, you can start to have a little look between the two. Even here in the monthly energy flows, we can see values of about 1.4 in March. That jumps up to 3.1. Clearly, we have very, very large solar loads coming in that is driving the unmet cooling hours in these spaces. We seem to be dominated on a Sunday. So there's something going on here. And the question is really, really what? I'm not going to focus on the performance cost, performance cost index and the Appendix G, just because effectively the format of what I'm saying here is very, very similar, and that's covered in other videos. So the question is, well, what's going on here? Well, let's ask the question. If we go into the office space, we can start looking at all the things that are going to impact us. Now, we noted the solar heat gain coefficient. We can bring this back down here. Let's just change that for the entire building and match it there, 0.25. I think that's probably the most meaningful thing there. Then if we go into the HVAC system, the spaces themselves, we can start looking at what's happening here. That Sunday was a bit peculiar from my point of view, something going on there. Okay, so we have all these data points on a Sunday. You know, do we have equivalent HVAC on the Sunday? That's probably the question that I would be asking. So effectively, do we have a schedule for thermostats and HVAC that enables, a conditioning to be provided? So if we look at that versus that, looks like we do. Let's look at the Sunday. We have the backstops. Looks like that's reaching up there. So it's probably the fact that we might be just dumping too much air into this space. There is our VRF now added on. Feels like it's a question of just dumping too much air. So going back to our HVAC system here, effectively, yeah, we've got no cooling coil on the air, all that warm air that's coming in. So kind of bringing in a alternative here. Let's what's that? I need to put on a chilled water loop. So let's go ahead and do that. Add components, add plant, chilled water loop. Just ignore what I'm doing here, guys. This is just providing some chilled water. Done. Almost done. Done. Okay, so we've now added that into there, and that is likely going to give us a significantly different outcome. So as that's rolling through, I'm getting to the end of our time. So I'm going to see if I can view any questions that might be coming up. Where are you? Where are you all? Okay. Sorry about that, guys. I'm absolutely having a nightmare of a time visualizing a couple of things. So let's scoot back now. Okay, I've got an unidentified object there. That's not going to help us run anything. Not even sure what that is. What have I introduced here into this? I don't know what I've introduced into this that's caused that. Sorry about that. What have I done? What have I set up wrong? I've set something up wrong. I honestly don't know what I've done there. No curves on it. Could be something to do with the fact that I didn't put curves on there. Let's see if that works. Anyway, so questions, guys. So there's only 12 of you there. Feel free to shout out. More than happy to hear your voices rather than listening to myself. Darius, it looks like you're frantically typing away there. Yeah, go ahead and if you can unmute and you feel comfortable speaking, feel free to shout out. I don't know what I've done.
Yeah,
here.
Sure.
Cool.
I was just going to
so
say...
there's no Open Studio error there coming through, so I'll resolve that in a second. Yes, sir.
I was just going to say that this is great. Seems very intuitive and fast. I was wondering if anyone has successfully used this software to demonstrate compliance under like certain different jurisdictions. I'm thinking like Lead, Massachusetts, New York City, things like that.
Yeah. No, we're fresh out of the blocks here. So we've only launched in the US very, very recently. So we've gone through this process many times. And effectively what we do in our documentation, we substantiate everything, show all of our testing. We reach out to as many people as possible. We take questions from authorities that need to ask them. So it'll take a bit of time, Darius. That's for sure. Yeah, we're not shy about that. But at the end of the day, we've got EnergyPlus under the hood, that should allow us to answer any question that comes through. So we're very confident. We've been through all of this before. So I'd say no, not yet, but it will happen. That's not an issue for us. Do you find authorities are pretty sensitive around the software? Because I think I've had that question come through a few times, and we haven't had that level of sensitivity from an authority perspective in the past. So is that something you think that I'm going to experience now over the next year or so as we start to promote this platform?
Potentially, I know for Massachusetts, which is getting more as a more strict building code, depending on the municipality, the software, the list of softwares that are approved to demonstrate compliance, you have to get approval from like each municipality to make sure that they're okay with it for that particular project.
And do they amazing? And do they have specific? Do they have specific approval processes? Because I do hear that quite a lot. And then you go through, for example, for LEED, there's no official process to go through to be identified as being a software that you can use. And reaching out to LEED, they go, well, as long as you're using EnergyPlus, that seems okay. But then you don't get an opportunity to say, oh yeah, cool, pop me onto that list, or I've done all the work now, go ahead and pop me onto the list. I'm just going to pull up this budget building variation that I made there just to sort of identify this change in the total number of unmet hours here. We can see that's now changed in the budget building just because I changed the VRF because of that EnergyPlus Open Studio area that was coming through. But anyway, hopefully that provides some answer to you, Darius. Anyone else, guys? Any other questions out there? You will find that this is a very, very quick process to go through. You can import models if you want to play around with bringing in an eQuest model or an IES model or a design builder model, in native or GBXML. There's lots of stuff I haven't shown you here today. So you can do all of that should you wish. Our documentation and support are all kind of available up here if you go for the documentation side of things, and if you look for user guide and deep in our workflows, and so we've got a lot of stuff here. You have all the information that you might want, and you also have constant updates coming through from us, and I think there's some contextual stuff that can be provided to authorities as well. I think there you go, like accepting better building simulation outputs. So we set things up to spoon feed authorities. So if they want to go through and ask questions, then there is all this information available to them. So no other questions there, guys. I guess if there's no other questions, I'll just go back and say, hey, was this clear? Was this clear enough for an introduction to the subject matter?
Hi, Darren. Great presentation.
Hey,
I
mate.
do have a question.
Yes, sir.
So I think you quickly went through how to set up model and had it simulated, assume all the unmet hours or other things going through. What is the automated documentation that is going to provide it for the authority to review? Especially like on chapter 11, it has a list of things that you need to show to the due AHJ.
Yeah.
Is this going to automatically do one PDF thing, or we need to go through different places to PDF?
We do have the PDF function there. To be honest, I haven't even dived into this. The one thing that I guess that I would say is that in the past, we've found that there's so much variability in terms of what people want to issue that we've been a bit standoffish in terms of implementing this particular item. I'm not even sure what we have set up here for this automated PDF. I'm just going to run it just to see what happens. But we can tailor that experience both to your company's brand, but also to the content of that documentation. And I guess where, for me, we'll see something like this being spat out in the PDF. So I don't think it will be all encompassing by any stretch of the imagination, but it can be. So it's kind of up to yourself to say, hey, this is the information that we want to see in this report and feedback to us. We completely recognise that we are modelling people, we're processing people, and we don't have all the answers. We certainly don't have an idea of what's happening on a state to state or even a jurisdiction by jurisdiction perspective. So if you had, I guess, an opinion on that, would love to hear it, because effectively we can build out what you need to build out, and we can enable you to add in more information into these PDFs as well to be specific to your requirements.
Yeah, I guess my question wasn't clear because there's a specific things listed in chapter 11 that needed for the submission. It's not ruled by me what I wanted. It's all listed in.
Sure. I do understand.
That's what I was.
I do understand that. What I was more getting at, and sorry I wasn't clear, is that even sometimes that changes in our experience. So I completely get that there is black and white stipulations within the process around what this needs to represent, and that's all fine. We can absolutely replicate that and make sure that that's extremely clear in the report. But we've just found that even sometimes that black and white, some jurisdictions say, no, actually I want this information as well and this information. So that's what I was really getting at. So I think I hear what you're saying. You're effectively saying, and just to get this covered for everyone else, that there is a bunch of information in here and it comes back back up here, this type of information here, that needs to be extremely clear in any automation that we provide in order for that to be accepted by an authority. That's kind of where you're getting at, right?
No, it's the end of this chapter.
The end.
Compliance. Yeah. It's the end or somewhere between the A, B, C, D, F, G.
Whatever. Yeah.
The long list.
The long list. Where is the long list? I don't know.
Oh, thanks, Alan.
Permit application documentation?
Yes, this is the list I'm asking for. Although, as I agree, each jurisdiction may ask different things, but if we meet all this, that's the basic requirement, I would say.
Okay, cool. I will take that. That's not an issue. We can certainly add that structure into this, and effectively what you'll see then is these results here will replicate most of what will be in that PDF. The only other additional things that will be in the PDF is if you bring in drawings, we can dump in drawings to the back of the PDF. We can provide specific calculations for thermal bridging and all that type of stuff. So that can all be added in there. 11.7. Thank you, Alan. Good man. I hear you. No problem. We can add that in, and we'll add that in next week. So we'll get that in there because I think it's a strong recommendation. Anything else there? Alan, you wizard, have you got any questions for me?
Well, thank you. So I actually wanted to respond to the Massachusetts.
Okay.
Massachusetts has two things, like they still use FXG, but it's site EUI. I think you guys can do like site BPF instead of just the energy cost BPFs, right? So I think that's pretty.
Yes. So we
that's
can.
an important thing for people to be aware of.
Yeah, absolutely. Thanks for that, Alan. Yeah, so I get your point. It's we've built out the specifics of alternative methods for the building performance factor. You can see them on the screen there. So yeah, that's a good point to make. Cool. Anything else about the energy cost budget method there, Alan? I mean, ignoring the kind of the results that have been shown here, because we've got to work through those unmet hours. But for me, it does generally feel that in many climate zones that it's probably less onerous than the performance cost index when stipulated under the standard BPFs. That seems to be our conclusion at the moment, but we haven't had enough experience in enough climates to really state whether that is actually the case. It seems to be roughly correct. Yeah, don't need to respond to it. Done. Okay, well, listen, guys, if you don't have any other questions there, I will give you back a few minutes of your time, which isn't much, but I do appreciate your time. It's what time is it? It's 4 o'clock in the morning for me now, so I get to do a couple more hours, and then I've got to give this presentation again. So I will stop recording